Autism spectrum disorder, otherwise known as ASD, and comparing robotic and human interventions. I would like to note that autism spectrum disorder will be hereon referred to as ASD. This presentation is about comparisons between robotic interventions, often referred to as robotic enhanced therapy or RET, and human interventions, often referred to as standard human treatment or SHT. Hi, my name is Menon, and I'm a current high school senior at Montgomery High School in New Jersey. Ian was my mentor and is an assistant professor at the University of California, Riverside. The reason why I chose this topic is because my twin sister, a few years ago, was diagnosed with specific learner disability, and I saw the difficulty she faced with learning. Through this, I started getting more involved in my community in helping children with ASD and similar disabilities overcome similar learning, social, and communicative barriers. Then, after doing some research on how ASD symptoms could be mitigated, I found that there was a lot of uncertainty on possible ways of approaching interventions to this end. As a result, I wanted to contribute to narrowing down methods. Additionally, in light of the growing use of AI, this topic of comparing SHT and RET seemed appropriate not only for my interests, but also in light of current technological advancements. So, what is ASD? ASD, according to Mayo Clinic, is a condition related to brain development that affects how people see others and socialize with them. Or, in more simpler terms, it is a neurological condition of which the symptoms include, among many others, difficulty socializing and communicating. The reason why it is referred to as a spectrum is because autism has varying degrees of severity. ASD has long-term impacts that go beyond the direct effects created by the symptoms. This is seen by how, according to the Northeastern Autism Society, or NEAS, 37% of those diagnosed with ASD drop out of pursuing an undergraduate degree in college in the UK alone. Furthermore, 40 to 85% are unemployed according to Rocky Mountain PBS. The reason why this range is so large is due to how autism is a spectrum and there are varying levels of severity within the spectrum. Before I talk about this slide, let me define what an intervention is. An intervention is a therapy tailored to meeting a goal depending upon who the intervention is targeting. In this case, the interventions are targeting children with ASD. This presentation contributes to trying to find the right type of intervention method. Currently, there is a lack of clarity on whether robotic or human interventions is the best method. This study tries to shed some light on this question and, through this, the question of what the right type of intervention may be. The thesis that this presentation is based on is how I plan to test my prediction that children with ASD pay more attention to human than robot therapists. So now let's dive into it. This study makes use of the DREAM dataset, which is a dataset of behavioral data collected from children diagnosed with ASD. It includes data from over 3,000 sessions, ranging from 3 to 87 minutes each in length. Each child, regardless of intervention method, undergoes an initial intervention, 8 intermediary interventions, and a final intervention. The image shown here is an adaptation of the setup for RET, showing the relative x-axis, y-axis, and z-axis for the data collected in the study. I will explain the differences between the SHT and RET more thoroughly in the next slide. In this dataset, data of the participants were recorded, such as the eye gaze in 3D space, using a sensorized table, which is not pictured here. Other metadata, such as the child's Autism Diagnostic Observation Score, otherwise known as ADOS, were recorded. The ADOS is a score that measures the severity of autism across different skills. If that combined score crosses a certain threshold, the person is diagnosed with autism. However, the data that is most important to my research is the eye gaze data, since it can be used to quantify the engagement the child has during interactions. Specifically, if the child looks at their surroundings more, which is shown by a high standard deviation of the eye gaze, they are likely engaged with the interaction since the task scripts used require the child to look around more. As a result, they are likely paying more attention to their interaction partner, which is either the robot or the human. Figuring out which interaction partner they are paying the most attention to can be used to deduce which intervention method, SHT or RET, is more effective. Okay, that was a lot, but now I'm going to move on to the comparison of SHT and RET, I promise, using a figure adapted from the dataset itself. The main difference between them lies in the layout of the intervention method. For the RET intervention method, which is located at the left, the interaction partner is the robot, which is interacting with the child. The robot is controlled by a supervisor, while the entire interaction is overlooked by a human therapist. For the SHT intervention method, which is located at the right, the interaction partner is the human, which is interacting with the child. The entire interaction is overlooked by a human therapist. Both of these intervention methods also use a sensorized table, which is located here and here. So the main difference between these setups is that SHT has a human interaction partner, while RET has a robotic interaction partner. In these interactions by the interaction partner, the task scripts they use center around 3 social skills: imitation, joint attention, and turn taking. A task script is a specific script that describes a certain executable task prompted by the interaction partner for the child to execute successfully or unsuccessfully. Now, I will go into some detail of the task scripts used in each social skill. With respect to the imitation skill, the child was prompted either to imitate objects, like playing with a toy car, common gestures, like waving, or gestures without a meaning. With respect to joint attention, the child was prompted to react when the interaction partner either pointed and looked at an object while giving a verbal cue, like look, pointed and looked at an object without giving a verbal cue, or simply looked at an object. With respect to the turn-taking skill, the child was either prompted to categorize objects presented to them or completing a series of pictures in a pattern. Now I will move on to the results of analyzing the standard deviation of eye gaze, which can be correlated with engagement and hence attention and the effectiveness of the intervention method, as I mentioned earlier. This is my hypothesis, which states the thesis slightly further to state that the standard deviation of the eye gaze data for human interventions is higher than that of robotic interventions for children with ASD. Using Jupyter Notebook and Python, I was able to analyze the eye gaze data from Dream. Specifically, I was able to generate this data table that organized the provided data into things like the participant ID and the standard deviation of the eye gaze for across all three axes, shown as Rx, Ry, and Rz. The tasks were also labeled as TT, IM, and JA, corresponding to the turn-taking skill, imitation skill, and joint attention skill, respectively. Another thing to note is that the reason why there are a bunch of finals listed in this column is because the standard deviation of the eye gaze was analyzed only for the final intervention. The reason only this was analyzed is because the more effective intervention method would allow for the standard deviation of eye gaze to increase across the preceding intervention sessions. Therefore, to effectively analyze which intervention method, SHT or RET, is better, it would be best to use the data from the final intervention. By organizing the data in this data table, I was easily able to create these three graphs and compare the eye gaze data for each intervention method, SHT or RET, across the three social skills, turn taking, imitation, and joint attention across all three axes, X, Y, and Z. For example, the top graph at the right shows the standard deviation across differences across SHT and RET for the X-axis across all three task scripts, labeled TT, IM, and JA. SEM bars were also included to account for significance of differences in standard deviation. Significance was further analyzed by using linear regression models, not pictured here, which compared the standard deviation to the intervention method. It ended up confirming that the average standard deviation of the eye gaze across all task scripts was significantly lower for SHT than RET for all axes, disproving my hypothesis. From this, it can be concluded that since RET has a higher standard deviation of eye gaze, it is more engaging and therefore more effective as an intervention method, disproving both the thesis and the original hypothesis. This ultimately contributes to efforts to narrow down and find the optimal intervention method to help mitigate the symptoms of ASD as early as possible. Additionally, this conclusion would assist efforts of implementing intervention methods to school curriculums and more to ensure that those impacted by ASD have an equal opportunity to take advantage of the resources available to them. Thank you for listening.
Wow, thank you very much for, again, another great presentation. I have a question. Are there specific children that, because we were talking about ASD as a spectrum, so autism affects every student, every child differently. Are there specific children that you think would benefit the most from robot therapy?
It's mainly the younger children because there's data out there saying that at around 3 years old, it's better to implement intervention methods. So like at the very early ages of development to help mitigate those symptoms as they grow up and and later on when they're in school and beyond.
Okay. And what was the most interesting thing that you learned in your project?
I think the most interesting thing for me was figuring out that robotic intervention methods were more effective than human intervention methods because it seemed to me that the child would be able to engage with the human more because it's more advanced with being able to communicate, especially with the fact that robots are developed but not as developed yet to be able to imitate those human interactions. So it really surprised me that by the data like the children are able to interact with robots more than the humans.
Okay. One last question. Kids also interact with humans more at home. Does this make an effect on their reaction?
Um, I like, do you mean like for the data, like with the data shown?
This was an attendee asked this in the Q&A. Do you want to add more? Yes, they said yes.
Um, let's make-
I'll,
so
I'll read it again. Kids also interact with humans more at home. Does this make an effect on their reaction?
I would say that actually with them interacting with humans more at home, it would actually produce the opposite effect, which is what I was like saying that's really surprised me.
Hmm.
Um, but it shows that pretty much that the children are even regardless of being interacting with humans more at home, are more attentive to robot therapists.
Okay. Okay. Um, and the person said yes. Thank you. It surprised them as well.